Today I'd like to talk about, or I'd like to show you a tool set for scraping with AI. And what do I mean by enterprise grade? Well, I'll show you. Some of you may have seen a diagram like this before. This is a technology radar. This one is produced by a consultancy called ThoughtWorks. And what they're doing here is depicting a landscape of emergent technologies, really on horizons of maturity, readiness for adoption. So some technologies might be out here around assessment or hold if they're not yet ready for production use because there's more maturity needed, more evidence of use, more of an ecosystem that needs to be developed before they're ready for trial or for adoption. And this is a picture that they represent quarterly. And as they observed with the latest one, a lot of the technologies they're depicting around AI, because AI is so fast moving at the moment. And so we're seeing rapid movement between technologies that are out there on the edges around assess and that are ready for production use, for trialing, for adoption, for use with customers. And I think we heard from Konstantin earlier that the use of large language models for web scraping, it's exciting. I think the word that Konstantin used was promising. But at the moment, there's issues. So perhaps the use of large language models for scraping at the moment is out here at the moment somewhere around assess, whilst the ecosystems around large language models are still developing. And that's a lot of work. There's a lot of work that we're putting into these, that the broader community is putting into large language models. But what I wanted to do today is share with you for the question of what can we use now? Rather than waiting for the further development and the maturity of these approaches, how can we derive value from AI now? But in terms of deriving value, we need to ask ourselves what the question is. What goal are we trying to achieve? And with web scraping, I tend to talk about two problems a lot of the time. Or these are two problems that I think we all talk about a lot of the time. The first is the cat and mouse game with bans. I thought Isaac's speech was wonderful in this, where he was talking about not only the range of technologies that are part of this cat and mouse game of battling with bans, but the need to do so cost effectively. I think he described it as the cheapest viable solution to a site ban. And that's a battle. It's in opaque environments and fiddling with headers and sessions and cookies to try to get a working solution at minimum cost. But the second problem that I think we talk about a lot is one of scaling. So I often talk to businesses who say, I need to tackle 200 more sites this quarter. And if my team had nothing else to do, that might be a viable goal. But much of the team is taken up with maintaining the sites that we already have, and I just can't scale fast enough. And there are solutions emerging in the market to each of these problem spaces. For the ban problem, we're seeing the emergence of web scraping APIs, where they're offering automation for the kind of processes that Isaac was describing, of selecting technologies, applying configurations, minimizing the cost. Web scraping APIs are offering automation around that space. And for scaling, we're seeing a variety of solutions. Low-code or no-code solutions, aftermarkets where freelancers are producing reusable spiders for use across a catalog of sites. But I think AI is the story that we've seen that's been most exciting in this space, and particularly the story around large language models. So we heard from Konstantin's speech. He leads data science at Zeit. We've been doing a lot of exploration, a lot of work with large language models, and we've seen a lot of positives in this approach, that they don't need a new model trained, and so they're fast, they're flexible. They're really good for unstructured data. We've had use cases where we've applied them to extracting structured content from unstructured fields, description boxes, because they may have data points in there, like dimensions, that we need to retrieve. Because large language models weren't developed explicitly for web scraping, they can offer something in a broader picture, like data processing or process orchestration. But we've also seen challenges, and again, we heard this in Konstantin's speech, that the ecosystem around them is immature at the moment. There's questions around reliability and accuracy, not just out of the box, but what strategies are available to manage that accuracy. They can be very expensive. They don't in themselves have the means to solve site bans or script the browser. And we've all heard some of the legal cases that have been arising around training using copyrighted content or when they pick up personally identifiable information. But again, if we come back to this goal, how can AI give us more scale and more speed in web scraping? How can it allow us to grow faster? What does a solution need in this space? Well, the two absolutes is that it saves us time. That is what we need in order to scale faster, to grow faster. And so we need to see improvements, both in terms of the ability to set up for a new site, but also in maintenance. It's often maintenance that chokes our ability to get more done. So these are the two absolutes in terms of driving time savings. But as we've seen from the last two slides, there's more that we need in a solution. It's got to be accurate. And we need to have controls over accuracy. We need to be able to validate accuracy and drive it. It's got to be cost effective. I think we heard from Konstantin's speech with ChatGPT-4, running it on every page can be as expensive as employing people. And clearly, we're not then seeing the benefits of AI. So this has to be superior on cost. For us to use it in production, it's got to be compliant. It has to solve all of the problems that we have around web scraping, like solving bans. And even more, it's got to be controllable. We have to be able to instruct this thing what we want to get from it, to run the crawl that we want, for the results that we want, with the data points that we want. This is not a small list in terms of having a production-ready system. This is all I want for Christmas. But today we'd like to show you this. Let's start with a simple demo.
So today, when you create a new Scrapy Cloud project, you're going to get a new option, which is using deploying sites AI-powered spiders. Now, these projects are going to allow you to use the web UI to create a spider that can crawl and parse any website, starting with e-commerce websites. So we select the e-commerce template, we give the spider some name, and we point it to any e-commerce URL. There are also a few other optional fields that I'm going to use, but are optional, as I said. And that's it. With this, we have enough to save our spider and just run it.
So while that's running, Adrian described that this is and we'll talk more about how the solution is working in a moment, but this is using a data model that's created for product sites specifically. You can use it on any product site. And okay, we're using an unbranded site for demonstration here, but we could have used this on any of the popular e-commerce sites. But perhaps just as interestingly, the unpopular sites, the long tail. Because automation like this can not only improve our current ways of working, it can open up business models that perhaps were unviable before. So sometimes we have use cases where we need not a lot of data from one or two sites, but a modest amount of data from a lot of sites. And that can be very challenging for the economics of creating and maintaining spiders. And automation can unlock that. It can make that possible. And we've seen that ourselves, that it opens up the means for horizontal scale as well as vertical scale. And we've got some results.
Yeah. So what we're seeing now is we already got some items, and this is what you would expect. Standard product schema with the usual fields: price, name, description, availability. All within minutes.
Great stuff. Can we come back to the slides, please? So what's under the hood of this? So this is a depiction of the process of web scraping. If we were starting by looking at the top left, this is the space of the browser, of solving bans, perhaps of setting geographies, of getting HTML in the format that we need, so perhaps browser rendering. And that's being done under the hood by Zeit API. So Shane talked about Zeit API this morning. It's a solution that we have that deploys a variety of technologies based upon the complexity of the site in question. And we have tiered pricing so that it only charges you for what's needed. And in that regard, it can be a set and forget solution because it can tackle the harder sites, but for the simpler sites, it's as cheap as a data center proxy solution. But what about extract? So this is an area that we've had in continuous development for more than 4 years. And previously, it was a separate product that we called Automatic Extract. And we incorporated that within Zeit API in July of this year. And it takes a different approach to large language models. This is a supervised machine learning model that was developed specifically for web scraping. And we've seen this allows instant setup. We saw in about a minute, we ran this on a site. We could have run this on any product site, and we got data out of this. But it also, as well as speeding up setup, it addresses the maintenance problem. And how does it do that? I'll show you in a moment that this is much, much cheaper than large language models. It's a dedicated model with a smaller footprint. And as we heard from Konstantin, when models around large language models have a high cost, one of the strategies for mitigating that cost is you don't run it on every page. Instead, you use it to generate code. But what happens when layouts change? That code's going to break. That code needs to be regenerated. Maybe it needs to be retested. So that approach is brittle. But because a dedicated model like this is much cheaper, we can run it on every page. And so rather than generating static code, it's dynamic. And so it keeps pace with changes with layout. Even during a long crawl, if a layout changed mid-crawl, it would manage that and keep pace. And so in doing so, it addresses the problem of maintenance. As I touched on, it's very cost-effective. It's around 50 times cheaper than ChatGPT 3.5. As we heard in the last speech, ChatGPT 4 is about 20 times more expensive again. So by being a dedicated focus model, it's much more cost-effective. It can be used in that different way. Runs in both modes, so it can run on HTTP response body, which is fast and cheap. During Adrian's talk yesterday, I think somebody asked a question around extracting from single-page applications. It can run against rendered HTML for sites that have a lot of JavaScript. But what about quality? So as we see on the table here, versus ChatGPT 3.5, because this is a model that was created specifically for web scraping, it's more accurate. Now we do, and Kevin touched upon this, we do ourselves see an opportunity for use of large language models, which we are using now and we will bring into Zeit API, specifically at this time for the use case of extracting structured data from unstructured fields. And so in this regard, we can get the best out of both solutions. By being focused on one field like that, we can manage the cost challenge of large language models. It's not needing to process an entire page. The supervised machine learning approach is much stronger where the data is in the structure of the page. There's a page element for the price and the title. And this is the vast majority of web scraping. So the combination of these two we see as being very powerful. Now, the data we saw there in quality is very good, but it's not 100. So what can we do if it's not 100? Well, we've got a second layer of quality here, which is annotation. So we've got human-in-the-loop approaches to AI. The models are trained on tens of thousands of websites. They can then be run on any website. But what if for a given website, the model's not giving a great result? Well, this is where our support team adds annotations. We don't need to retrain the whole model. It's a small amount of data, so we can deploy that same day. And we find that when we need to do this, because a site needs it, of those cases, this can solve about 80% of them. What about the other 20%? I'll get to that in a moment. We do have an answer. Now, the schemas, because this is a model which is trained for data types, products, articles, jobs, and so on, it has a defined schema. And so that gives one nice advantage straight away, that it means if you're extracting data from multiple sites, they will all have the same schema and the results, and so you can easily union those together. But secondly, as we develop these schemas, we govern them with our legal team. And that means we exclude from the schemas data points that could contain personally identifiable information or copyrighted information. So there's a layer of governance and compliance out of the box that's built in. So you can run this with compliance confidence. What about crawling? So far, everything I've been showing has been Zeit API for automation, using machine learning and automated approaches for solving bans, for extracting data from the page. Crawling is done with a scrapey spider. And that's because at this step, you can take control over all of the rest. And so we've produced open-sourced scrapey spiders for common crawling strategies, keywords, whole site, and so on. And we saw in the first demo, we can just run that and get the results. But also, you can take that and copy it and edit it. And in doing so, you can take control of the crawl if you want to alter that. You can add further data points if a given site has a data point that's not in the standard schema. If the two layers of quality I described, a powerful model, a layer of override for individual sites, If that's still not perfect quality for a given site, you can override it by editing this spider. So in doing so, this gives you complete control. But let's take a look at this.
So the spider that we just created and ran during the UA demo, that's actually a scrapey spider. And to be honest, it's a rather simple scrapey spider. It has only two callbacks, parse navigation and parse product. We are now going to see how we will go about extending this spider to modify both the crawling and the parsing. We are going to modify the parsing so that we can filter by price and only output products above a certain price. And we are going to also add a new field to the output using custom extraction code written by ourselves. Now, the first step, the filtering, would be done by subclassing this upstream spider, scrapey spider. We first would add this new field that we are going to expose to the UI in Scrapey Cloud, but it's going to be basically a regular Scrapey argument. So we modify the arguments of the spider to include that new field. And the next step is to override the parse product callback to use that new argument to drop products that are not meeting the criteria. Now, the second step, extending the output with custom extraction, would require first creating a new output item based on the standard one that Site API uses, and to add a new field to it. Then, in the overriding of the parse product callback that we did, we ask Site API to give us, we ask Scrape itself to give us that type of item. And finally, we create what we call a page object, which you can think of as a parsing class, where we define that whenever we request such a new item type from the books to scrape.com domain, this code is going to be used. And this class is going to, by default, extract all standard fields using Site API automatic extraction. And we are going to manually define how to extract a new field. In this case, we are going to scrape the stock, the specific number of items of this book, in this case. Now, I have already deployed this code to Scrapey Cloud. So we can now select this new spider that we have created as a template. We are going to basically fill it as before. We need a new name for the spider. We can use the same URL, same optional fields. And now we can also set a minimum price, let's say 40 pounds. And this is enough. This will have the spider running. Now, I want to, I don't know how many of you actually know how Scrapey works. And those of you who do may have noticed that there are a few things that are not usual in the code that we have seen. We are using everything that you have seen code-wise. It's open source, everything. We're using a library called WebPoet that we have been developing for a while, which allows you to separate the crawling and the extraction parts of the coding to keep things more maintainable. And it uses dependency injection to work. And we have also created a plugin for Scrapey called Scrapey Spider Metadata that allows you to define arguments with clear criterion, parsing, and additional metadata, and expose them to Scrapey Cloud. And these are the results. We can see the stock price now, the stock amount, sorry, extracted with all the rest of the data from the API. And I mean, it's going to be a bit harder to look at, but all prices are going to be over 40 pounds. Back to you.
Great. So I think one of the nice features that we saw there, aside from control, is potentially supporting a split set of roles within a team. So Adrian modified the crawl there, but he didn't do so by hard coding a value for that crawler, for the filter. He added an additional parameter. And then when we came back to the UI, that parameter appears as a field in which you can make an entry. And what we're seeing that as being nice for an organization where perhaps within your teams you've got data consumers, data scientists, users of data, and then separately you've got engineers. And that arrangement makes a way of working, I think, quite elegant, where the data consumers can say, OK, this out-of-box solution is nice, but I need this, this, and this. And then the engineer can add those to the spider, and then that's just runnable by the data consumer again without needing any particular coding skills. So it creates a nice separation of concern between those two roles. Can we come back to the slides, please? Now, we do eat our own dog food with this. I've never got around to Googling where that phrase came from or who used it first, but I'm a fan of that. If anybody knows, please let me know. But Zeit is a two-part business. So we are a software business making tools for web scraping professionals, but we're also a service business for organizations that need data, but they don't have web scraping teams. And we've got a large professional services team of around 100 professionals. And we've been using pre-release versions of the technologies that we've shown you today for some time, and we've seen significant savings in our work, saying around a 50 to 80% reduction in setup and / maintenance. Why not 100%? Well, we're always going to be doing QA, data QA. So with any given site, we're going to be asking ourselves, can we use this site with raw HTML, or do we need browser rendering and to extract data from that version? Are we happy with the results out of the box, or do we want to run our quick fixes approach? Does the customer want custom fields? And so this is where we see that spectrum. If the driver towards kind of 50% savings is more where customers are wanting custom fields. If it's merely a question of quality, it's more at the 80% saving. So we're seeing significant advantages from this. But so the driver here is, okay, it's not 100%, but that's because it's unlocking the standard, it's automating the standard. And really, that's what AI is about. This is not about replacing skilled professionals. It's about allowing skilled professionals to focus not on the standard, but on the custom, on the unique, on the value add. And this is what we're seeing it's allowing us to do. I touched on, with Adrian's first demo, about this unlocking new types of opportunity. So our services business, organizations come to us because they want data. Sometimes business come to us with a one-off need. And we've struggled at times to make that economics work. When we talk about setup projects and setup costs, if a business has a one-off data need, economically that just doesn't work. But through this kind of automation, we're seeing that shift. We're able to now start to offer one-off data sets to customers because of this automation, where it makes economic sense in a way that didn't before. So at the beginning, spoke about the technology radar, emergent technologies, technologies that are still developing. And I was asking, what can we use now, whilst these technologies are still emerging, whilst they will add on? And in order to be used now, these were the parameters that we were saying that a production-ready solution has to have. And the top two are just absolutes. To hit our goal of allowing us to scale faster, it's got to be saving us more time. And we've seen today with the first demo an instant setup. And because this approach is much cheaper than large language models, it allows it to be run on every page. So rather than generating static code, it's dynamic. And in doing so, it addresses the maintenance problem. So between these two, it's saving significant time, as I touched upon. It's high quality. We can see the models out of the box are high quality, but we've got two further layers to manage that quality. The hinting process that our support team do, but by controlling the spider, you can override the extraction if there's still a quality issue on a given data point. It's got out-of-the-box compliance. The schema is governed with our legal team to remove fields that contain personally identifiable information or copyrighted content so that you can use it with confidence. It's a complete solution that includes sophisticated anti-ban that was rated recently by Proxyway as the strongest in the market, so you can have a set and forget scenario around bans. And finally, it gives you that control. As we've seen with that spider editing, we can control the crawl, we can add further data points, and we can manage the quality. So this is a solution that we are using in our own services business, but we'd like to be able to share this with you. So the elements of what I've described have existed for some time. Zeit API, it's mature. Our auto extraction, we've been developing for 4 years. It's got to very strong results now, it's mature. The element that's new is the open source template that we've just showed you today. This is going into beta today. We'd like to share this with you, so you'll all be receiving an email shortly with setup. We'd love it if you gave this a try, and if you gave us your feedback. And to say thank you, we'll give you some free credit for that, so you can try it out and make use of it. Thank you.
Okay, so we are going to take a break in a minute, but we have a few questions. Here's some we prepared earlier. Okay, so let me see, where will we start?
I can take the top one.
Top one.
Oh, it just vanished. There was a question there about... I'm sorry, go on.
Yeah, go for the top one, yeah.
There was a question there about how can we manage Cloudflare with Zeit. So if anybody would like to Google Proxyway, you'll see a review that was released last month. It was reviewing 5 web scraping APIs, and Zeit API came out very strongly. They tested all of us against 7 sites. And why 7? Why those 7? It's because they had a range of anti-bot technologies used by those sites. So they were using Cloudflare, Akamai, Shape, Datadome, a full range of anti-bot technologies. And Zeit API was shown to be effective against all of them. So don't take my word for it. Please have a look at that Proxyway review. So you'll see that by raising a request to a site via Zeit API, it deals with Cloudflare.
Just a quick one here on the annotation tools that were demoed earlier. Are they going to be available for customers? Do you talk about that one, Iain?
That's not the intention in the short term. The intention in the short term is that we stand over the quality of the data, that we monitor, that we've got a support team, that we can apply those corrections ourselves, essentially so that we do that so that you don't have to. Is there a case for people being able to use those themselves? There may be. But in the first instance, that's a service that we think we should be providing as a value add.
Thanks. Just following on the data kind of consistency problem, the top question here about, how do we ensure the consistency of the schemas and the quality of them as part of automatic extraction?
Well, I guess that's in 3 layers. So firstly, we monitor the quality of the results. We saw that on that table, that 2-sided table of large language models versus automatic extractor, we monitor the consistency of results. But then we've got 2 further layers to manage that quality. The first is that hinting process that I just described. So the models are developed they're trained on tens of thousands of sites. You can then run that model on any site within that category, products, jobs, articles, and so on. But what if for a given site the model is not accurate enough? Well, then we've got that second layer about adding the hints for that individual site. That works 80% of the time. What if you're in the 20% that doesn't work for this site? That's when you can take control at the spider level. So you can override the extraction directly in Scrapy, and in that way guarantee the quality.
And the other thing on those extraction models, and maybe this is a question if somebody wants to grab Constantine at some point, but those models are essentially been trained. We've been trained for like 4 years on all sorts of different data, particularly product data, articles, and so on as well. So we have a whole process for how those models essentially build up their quality. Adrian, there's a question here about maybe you could take this one on the documentation and the open source repo where the code is hosted. This one here.
The open source repo, we can probably share them later, but WebPoet is the libraries we use are WebPoet and Scrapy Spider metadata. We are also going to release, if we may have already done it, sorry, I'm not in sync with the team, both a library that is going to provide those e-commerce website, e-commerce spider that we saw, that's going to be in a library. And there is also going to be a project that uses the library, a template for a Scrapy project if you want to use it as a start. But you can also take a existing Scrapy project, just add this new library, and you will get access and have the ability to create new or modify existing spiders to use this technology.
Okay, thanks. The results of this product, are they going to be similar to our automatic extraction product?
Yeah, I think I can take this one. So just to be clear, what we saw today is actually Zeit API automatic extraction working. Like we are providing a framework with Scrapy as a base and open source libraries to basically use the existing automatic extraction of Zeit API to make automatic crawling possible and easy to achieve and to customize.
But what I would add to that is, I described earlier that we pulled automatic extraction into Zeit API in July. We associated that with a further round of work. We've been developing automatic extract for more than 4 years. We've been continually progressing its speed, its efficacy, its cost. At the point of transition into Zeit API in July, that was associated with a further upgrade, and the accuracy was increased at that time. So if you're used to seeing success rates from automatic extract as a separate product, please try it in Zeit API. You can access it from a single subscription, and you'll see that the success rates have got stronger since it was a separate product.
So there's a question there about the data sets using, for the supervised model. So I'm not even going to attempt to ask that, but I am going to get Constantine to answer.
Yeah, regarding datasets, I don't think there are good public datasets available. Like, I think there were a few small-scale datasets, but they have very few websites. We open sourced 2 datasets, one for article and one for products, but they were in the context of evaluation, so they have like around 100 or 200 websites. And also, so if you want to train your own model, I would recommend you to look into semantic markup. Like, there are Web Data Commons datasets where like the pages are annotated with semantic markup already, and there are like millions of websites you can scrape and use this markup as a source for your training data. And this is an approach we use to bootstrap our own model and then improve them further with in-house datasets.
Thanks, Constantine. Okay, so I just have one question, Iain. What about other types of data? So you demoed it on product. What's the thinking?
There's 2 parts to the AI-driven extraction that we've seen here. There's the extraction and the crawling. We've got mature models for product, articles, jobs, vehicles, real estate, I believe. But for the solution we saw, we need both the model and the crawling capability. Got product right now. We'll have article before the end of the year. For jobs, we need to do a bit more work on the machine learning of the discovery of jobs. The extraction is fine for extracting an individual job, but for the crawl, for the discovery, we've got a bit more work to do. So jobs will be in the new year, but others will continue to appear.
Okay, thanks, guys.
Right.
So I think we're saying 15 minutes, so it's just after 11 here in Dublin. We will start probably in about 15-20 minutes back again. Okay, thank you all.